Hello and welcome to another video in which we're going to be explaining another definite integral concept of Barrow's theorem, which is to find and solve the area between two functions that do not intersect in two different points. So let's just show what we want to solve. Here we have our x-axis and here we have our y-axis, our point 0. We have one function, let's call it f of x, and we have another function. Let's call it g of x. And we want to find the area between this point, point A, and this point, point B. So we want to find this area. To do this, we apply Barrow's theorem, and we do it following the following formula. Upper limit B, lower limit A. Remember that your B must always be greater than your A, which in this case it is. As we see, it is further along the x-axis, so that means it is greater. And it is going to be f of x minus g of x dx. And what you always need to make sure here as well is that between the points of A and B, all between these points, your function, first of all, that it does not intersect. If not, this formula does not work. And also that the f of x is greater than the g of x. It is higher up. So if this one was our g of x and this one was our f of x, we would need to switch these as the formula would not work. So your f of x needs to be greater, your f of x needs to be greater than your g of x for all x's between points A and B, including A and B, and also that the two functions cannot intersect between these points. If then our function goes like so, and they do intersect, then that's fine, that does not matter. But between A and B, they cannot intersect. Let's practice this concept with an example. So we have f of x, which is equal to x squared plus 4, and we have g of x, which is equal to 2x. So we could just immediately apply it, as we know that this are f of x and g of x, but actually these are just the names of functions, and this formula is obviously just a generic name they give to function 1 and function 2. This could be h of x, this could be z of x, this could be any letter. So here we have to really make sure that between the points, and let's already give the points, a equals 0 and b equals 2, we need to make sure that one of these is above the other. So let's just, very simple, choose a number in between these, or even the same a and b, as they have to be greater in a and b as well. Let's just choose 1, for example, which is between 0 and 2. Let's apply f of 1. We're going to get 1 squared plus 4, and this is going to give us 5. And then if we do here in our g of 1, 2 times 1 is going to be 2. So our f of x is greater in this case. Let's just write it down then. X squared plus 4 minus 2x in points 0 and 2 d of x. And we're going to get basically 2, 0, x squared minus 2x plus 4 dx. We can solve these individually, so we know that this is going to be, x squared is going to be x to the power 3 over 3 minus 2x is going to be x squared, and 4 is going to be 4x, and this applied in 2 and 0. Obviously, if we apply 0, we have x's in all of our values, so this is just going to be 0, so we can cancel out 0, and if we apply 2, this is going to be 2 to the power 3 over 3 minus 2 squared plus 4 times 2. And this is going to give us 2 to the power 3 is 2 times 2, which is 4, and times 2, which is 8. So 8 thirds minus 2 squared, 4 plus 8. And this is going to be 8 thirds plus 4. 4 times 3 is 12. 8 plus 12 is 20. So our area is going to be 20 units squared. The area under the area, in between f of x, x squared plus 4, and g of x, 2x, between point 0 and 2 is going to be 20 over 3 units squared. And that's it for today. Thank you for watching, and in our next video, we'll continue to practice with exercises similar to this one in order to understand this method.